Hey everyone, it is January 2022 and it's our first pancake breakfast of the year at the New Stack. I'm Alex Williams, founder and editor-in-chief, founder and publisher of the New Stack, I should say. We have Joab Jackson here, who is editor-in-chief. But we are so excited to be part of Chaos Carnival 2022, hosted by Chaos Native, who are sponsoring this pancake breakfast. And so just want to say hello, get things started by, hey, I just have a quick question, Ramya. I understand you know what you're doing when it comes to pancakes. Can you show us?
Of course. How is it looking, Alex? Let me zoom it for you. How is it?
That looks good. Awesome.
Oh, thank you.
They look delicious. Kartik, I like the outfit. Looking good. Charlotte, I like the hat. Does anyone have any syrup or anything like that? Because I brought my pancakes and I'm glad I'm remote.
Here's some syrup, Alex.
Okay, thank you. Thank you.
Got that?
Oh, a little trouble in the transformation there, but maybe the radioactivity that surrounds me right now. I'm not quite so sure. All right. Hey, Charlotte, what's the equivalent of pancakes in your part of the world? Because I believe you're in the Netherlands.
I was gonna say, because my pancake is a lot flatter, so this is the German version actually, but I think it tastes pretty similar.
I'm sure it does. Nora, how about you?
I did not get a chance to make pancakes this morning.
Oh, do you like pancakes though? Do you like pancakes?
I do. I love pancakes. Big
All
fan.
right.
I wish I could get some virtually. Yours look great.
We'll have to have a pancake reunion at some conference with all the pancake speakers out there, and we'll share pancakes with you. But in any case, our topic today is observability, and I'm really excited about this topic because we're looking at it from the point of view of the cloud native enterprise. And let me introduce our guests, who of you have met a little bit now, but I'm going to introduce them formally. We have Kartik Sachinanda. Kartik, can you pronounce your last name?
It is Sachidanand, you're close. Yes, you can just call me Kartik.
Kartik, thank you for joining. He's co-founder and lead open source at Chaos Native. Ramya Ramalinga Muri, who's industrialization head, reliability and resilience engineering at LTI. Hi, Ramya.
Hey, Joe. Hi, Alex.
Good to see you here. And Charlotte Mock is a cloud native engineer at Container Solutions, a second-time participant on our podcast. So, Charlotte, great to see you back.
Great to be back.
And Nora Jones, founder and CEO of Jelly. Hi, Nora.
Hi, Alex. Great to be here.
I want to get started with talking a little bit about what engineers face these days. And I've been thinking a lot about this. I read the story about Uma, one of the co-founders. And one of his points is that what we really see with cloud native technologies is how many more components there are. There's so many services that people use. There's so many versions. There's so many dependencies. You can't start to see why you need to be prepared for all the possible scenarios that might emerge when perhaps there is a component that's not part of your core service, that's a third-party component, that might have an issue, right? And so that can really affect your overall service and how and its reliability. So I'm curious how this science is evolving and how we're starting to think of how we can prepare for these different kinds of faults. And I thought, Kartik, it might be a good opportunity to talk a little bit about what you are just announcing, so we can get a kind of perspective on it and look at it from a market point of view.
Sure. Thanks for setting the context, Alex. I think you made a great point. There are just innumerable dependencies in an average software stack today. A lot of versions, maybe they're changing too fast. The deployment models have changed from what they used to be, let's say, a few years back, right? So it is really imperative for us to be able to verify the resilience of our system overall, of our service overall. And the one way to validate that, and when we say validate, of course, we've been doing as an industry a lot of testing, a lot of best practices around CI/CD and similar such. But the sheer complexity of today's deployment environment makes it imperative for us to go test in production, makes it imperative for us to test the interdependency of all these components. The surface area for failures is so much more. And we need to be doing it at runtime, preferably in production or something that gets as close to production as possible, which is what chaos engineering is all about. The word can be a little intimidating. We've had a lot of good sessions yesterday. In fact, there was one speaker who suggested we should not call it chaos engineering, rather we should call it reliability engineering. There are different ways of sort of feeding it to the people, selling it to the people who matter. But what we just announced today, and that's on the back of what we've done as a community and as an organization, Litmus is the chaos engineering solution that we've built an enterprise version on top of chaos native Litmus. It is going to help, or it aims to help people with their chaos engineering needs try and verify how resilient their systems are before they ship, and of course continue to test it after they ship it as well in production. And there's a lot of philosophy around chaos engineering that has got built over the years, what it means, how it should be done, what it is not. For example, Nora is here. I think we've all had a chance to read the wonderful book that she has written about chaos engineering. So the principles of chaos is something that we took to be our spiritual guide in this process of creating the community and the tooling, Litmus, of course, on top of which we've created Chaos Native Litmus, which helps you with all the other enterprising needs around chaos engineering. So that is a very quick take, Alex. I just wanted to call out, just agree with you on the complexity that exists in the deployment environment today, and what chaos engineering can do to help there, break things in a controlled way, validate your hypothesis, reaffirm your assumptions about your system. And then there's a lot of tools to do it. And what we've just announced today is one means to help.
Excellent. Nora, Nora, how would you follow up on that?
Yeah, I think we've seen the field evolve a lot in the last 5 years. I mean, it really started coming into prominence, I think, in later 2017. I got the opportunity to work on the Netflix team that was open sourcing a lot of these tools, and we worked on a tool called CHAP as well. I think especially with the amount of services in play, you are not going to be able to hold that information in your head anymore. I mean, with our complex systems in general, you're not able to hold all that information in your head. And I think a big part of chaos engineering that is around to stay is understanding where to experiment and understanding how your system works a little bit better through these controlled experiments. I think one of the pieces that's becoming a lot harder over time is picking the experiment that you want to run. And so, thinking about the original principles of chaos, like how have they evolved since our systems have gotten more complex, since that we're doing cloud native a bit more, is going to be really, really important to keep in mind. And there's a few ways that we can go about recognizing where in our system to run experiments in ways that are going to have a lot of ROI. I mean, you can run an experiment kind of anywhere between services. It doesn't necessarily mean what you're finding is going to be likely to happen. And so that's a lot of upfront prep work that the teams and the people running these are going to need to take.
Okay. I want to just remind the audience that we are taking questions, and we're glad to answer those. Joab, do you have a question that you'd like to ask to start off?
Yeah, I'm very curious. We've covered chaos engineering from the Netflix perspective for a while now, as well as from commercial companies like Gremlin. But what are the specific challenges with chaos engineering for the cloud native environment? I imagine there's a more complex. What are the differences? I don't know. Maybe Nora, you can jump in on that.
Yeah, I mean, I do think there are a lot of differences to keep in mind. I think the biggest one is that it becomes more complex when you're creating experiments too, and creating experiments between services. I think we just have a lot more to work with in our heads when we're creating and understanding these experiments, and also understanding what to do with the results.
Yeah, I'd probably like to add to what Nora said. The picking the right experiment is just so difficult in the cloud native world. That's absolutely true. Mm-hmm. There's another aspect that sort of differentiates cloud native chaos approach, and we've talked about this in a few articles. There was one that was published in CNCF recently that Umar wrote. The cloud native chaos engineering is also about how you practice. How is the operational aspect of chaos engineering different from what it used to be earlier? People are used to a certain way of life when it comes to cloud native operations, right? Everything is declarative. Maybe it's all YAML. Everything is driven by Git. You want the same way to manage. You are looking for homogeneous experience in terms of managing your chaos infrastructure, your experiments, your results and observability, just as you manage your microservices, which are also cloud native in nature, which you're managing on your clusters. So a lot of tooling that is evolving now under this subcategory called cloud native chaos engineering adheres to these principles as well, along with the original principles of chaos, the fact that you need to control the blast radius, you need to hypothesize, you need to automate. There's also these things about how are you expressing your chaos intent? And how are you expressing your hypothesis validation intent? How are you executing it? How are you consuming the results? A lot of these nuances have gone in to make this a definitive subcategory to chaos engineering, to cloud native chaos engineering.
Couldn't agree more, Karthik. Rightly said. One point that is really imperative in cloud native, which I could think of, is observability, right? So with Kubernetes putting down another abstraction layer after infrastructure and just between the application. So it is very important that we need to have a very strong observability capability to understand what's happening in Kubernetes, right, at that layer. So that is something actually we feel, yes, having an orchestration engine solves a lot of purpose, definitely, but it creates additional problems, or I would say challenges, in terms of having a very strong observability. It is not a luxury add-on. In a core chaos native environment, observability across all the layers and the capability to do a correlation of different logs, traces becomes much it explodes, and it is much more complicated than the traditional chaos experiments, is what I would like to add on, Karthik.
So with Litmus, is that observability done through Litmus Chaos, or do you work with like Grafana and Prometheus and all the other cloud native tools?
Yeah, you're right about that. So there are two aspects again to observability. The fact that you need to ensure, as part of the experimentation process, you need to ensure that you're consuming a lot of observability information that's around you. For example, let's say you're running a chaos experiment. You know that your experiment is going to create some impact, and there are certain measures or certain ways for you to look at that impact and consume it, right? A lot of the times you'll have SREs peering into these APM systems and dashboards, and they know what's happening. But a lot of the times you're also automating, you're running these experiments maybe as part of some nightly run, you're sort of doing random attacks. You have a chaos service that is powering some random attacks. You're doing it as part of a pipeline. You need to be able to make a decision on what has happened during the experiment. And that would need you, when I say you, the chaos framework, to consume what is around you, that is, what is coming out of Prometheus or Dynatrace or Datadog or whatever monitoring platforms that you're using, into influencing the verdict of an experiment. And this is a very subjective thing. Litmus does not mandate people to rely upon the verdict of an experiment, but all the same, it does not refrain from providing a result to an experiment. It is very opinionated, but you could actually make use of that feature. You could factor in a lot of observability information that's there in your ecosystem and use that as a means to say whether my experiment's hypothesis was proved and therefore the experiment passes, so to say, or whether it is disproved and therefore it fails. That's one aspect. The other one is, as a framework, you would also need to be generating enough hooks or providing enough hooks, generating enough information for you to instrument what observability mechanisms you already have. You might be using Grafana, you might be using the same Datadog or Dynatrace. You might want to correlate. There is an experiment going on at a given point of time. You want to know that a failure or a system behavior, maybe there's a deviation in steady state, whether that was caused naturally, maybe there's actual failure happening in your system, or maybe that's the result of a chaos experiment that's going on. You would like to know these details. So maybe logs, metrics, events, what have you. You need to have the framework generate all that information. And like Ramya said, you need to be able to correlate that with the application behavior that you're seeing at that given point of time. So Litmus does both. And Chaos Native Litmus, the enterprise version, just builds upon those capabilities with some additional integrations.
Karthik, just as a practitioner, I just wanted to share my experience, right? So on this particular context, no? So basically what happens, I mean, I see a small to medium to large enterprises where I help on bringing resilience and reliability engineering transformation journey. What I could see is majority of the enterprises which are till level 2 or level 3, they have a lot of excitement to carry out different type of failure attacks and the workflow of attacks, all that is, they are doing it pretty well. But where they actually miss is on the observability. So it is not just about carrying out different type of an attack and then calling it out as a pass or fail criteria, where I always advocate them just to look at chaos engineering as a journey to keep improving. In order to do that, I think observability should be the more, I mean, I could see a lot of excitement when it comes to carry out a lot of attacks, which is absolutely good, which is good. But beyond carrying out different type of failure attacks, which different use cases, that is really good. But the importance of it can be achieved. The outcome can be really beneficial unless and otherwise we have a strong observability. And that is something which I could see majority of the time is always not in proper place. As a practitioner, that's something which I could see across mid to large enterprises who are on a chaos engineering journey. Karthik.
Yeah, great point. I completely agree.
That's where the science part comes in, right? That even if an experiment fails or doesn't meet your expectations, you still learn something, right? That's how you differentiate between we're just building something, but instead we're actually doing these experiments to learn something about our current state. And then hopefully improve that state depending on how we did it.
Is that something you hear from customers who are trying to figure out how to prepare better when you're thinking about all these components and these cloud native environments?
So for my customers, a lot of them are still in the earlier stages. So I wouldn't say they're like full on cloud native experts, right? So something like chaos engineering for them still sounds like magical future thinking, but they're looking into it as a way to feel safer about their systems, right? They might not be used to all the moving parts and all the new things that they aren't used to. So chaos engineering can help them get the safety feeling that if we try something breaks or we break something, what does happen? Do we actually get the outcome that we want to have, or does something else happen? So this is kind of the safety net you can give people in the beginning.
What we did get a question from the audience. maybe we could post it here, and then we can then see who would like to ask it. I think it's interesting question by Dashant Sani. He's a practice leader, ISV and horizontal tech at Nagaro. And he asked, what are things to keep in mind while designing your thoughtful chaos experiments so that it helps achieve outcomes faster? I think this goes to kind of a little bit what Charlotte's saying. And Nora, I was curious on your take on that.
Yeah, I love this question, by the way. We actually, the book that got referenced earlier that I wrote with O'Reilly, we have a whole chapter 9 is completely dedicated to this question, actually. I think a big part of what makes a chaos experiment good is the prep work. Like, I think that is the hardest part, and it's a really hard place to know where to start. And I honestly see a lot of companies wanting to do chaos experiments and kind of like what Charlotte was saying, like wanting to feel more confident without necessarily taking the time yet to look at their previous incidents. And there's a lot of data in your previous incidents, and like things I would really encourage companies to look for before you start your chaos experiments is looking at your previous incidents and seeing what surprised people, where people had to pull in other folks for help, because those are things that are kind of revealing gaps in knowledge. And that's going to be the highest benefit of running a new chaos experiment, is gaining that new knowledge and gaining some of that new expertise. And so I really encourage folks to actually look at the things that have already cost their company money, have already happened, and seeing how you can expand upon that. And not only just looking at single incidents, looking at patterns across incidents, like, oh, wow, we really need to bring Venkat in for all of our Kubernetes incidents. Like, how do we disseminate the knowledge that he has about Kubernetes to other folks in the organization? And having him kind of stay silent during that experiment, and having other folks come up with the hypotheses, come up with the prep work. I think a lot of the work is going to be done also talking to folks in your org and seeing what scares them about the system, what aspects of the system kind of keep them up at night. Those kinds of things.
Kartik, do you have
Charlotte,
any thoughts?
I'm super curious, like with what you said too.
No, I
Yeah.
totally agree.
Sorry, I think my internet messed up.
For the design,
Charlotte?
kind of, you're trying to reverse debug your system, right? You're trying to figure out things that could break it. Instead of going the way of something is broken, let's figure out what caused it. We're kind of going the other way. And that's the thing that I always find interesting, the way of getting there, right? It kind of changes the way you have to think about things that might happen to your platform or your system.
Just to add to what the Charlotte was saying, I would recommend having thoughts on having zero trust. We call this often in the security environment, right? So I would recommend all the dependencies. You should have a zero trust on the resilience level or a performance or scalability on all the dependencies. So that is the kind of mindset we need to have during the development or during the testing. When you come up with the use cases, start with, you do not have any belief on the dependencies, and you start writing down what all the use cases it could fail. And I think that would give again a very handful list of various chaos, and it can be always fit into a workflow, and it could be prioritized and managed. So do not trust anything that you're distributed, because you're going highly distributed. Do not trust anything, and I'm sure the use cases would start flowing. That would be a very simple approach to start with, to come up with a lot of chaos use cases.
Yeah, I completely endorse all these views. Just to build on what Ramya was saying, you could just apply the Murphy's Law, the altered version, if you will, for software engineering. Everything fails all the time, right? If there's something that can fail, it will fail. So past incidents and history is a great way to build a set of cases that you can prioritize. Analysis of your architecture and code, and finding out what are the dependencies and identifying what happens when they fail is a great way. There are some techniques that sort of help you along this process, something that we've been learning of late as well. It's the concept of a service catalog. So you know that these are the services in your system. This is how they talk to each other, and this is how they're going to be important. What is the potential impact of one service going down, and how does that cascade into your system? What is the extent of user degradation that can be caused because of some random failure in one of these dependent systems? So these are things that we would hypothesize about. And chaos engineering, like Charlotte said some time back, is also about learning new things. There are known knowns, unknowns. There's this entire quadrant about known knowns and unknowns. You have known knowns, the known unknowns, the unknown unknowns, all sorts of things you know about, and you expect things to behave that way strongly. You believe strongly because you've already tested it before you've seen it in practice. There are a few other things which you know have to behave a certain way, but you've not had the chance to see it working that way. Then there are a few things which you've not thought about at all, which you'll find out much to your chagrin when you're actually running these experiments. So I think these are all great ways to approach chaos engineering and create use cases.
Absolutely, Karthik. I mean, there is one point which comes to my mind when we talk about the unknown unknowns, right? So typically, then when we deal with these problems, it's not just about identifying the high availability problems. More, it looks very simple at principle, right? When I look at it. So are we creating enough experiments to ensure to test whether my application gracefully degrades, right? So we definitely there is failure is inevitable, as you rightly said. We try our best to ensure there is no failure, but yes, there are a lot of unknown unknowns which you cannot 100% predict, which is a fact that we all have to accept. But in such situations, how are we ready to handle is a very important aspect that a chaos engineer has to think through. And look for a graceful degradation is I think it does wonders, though it looks very simple, but actually it does wonders in many problems that we have seen in practice, is what I would like to add to.
Yeah, I think the whole paradigm of circuit breakers was sort of built. I think Laura can speak more about this. Hystrix, I think, was a result of all the chaos engineering efforts at Netflix, and people wanted to isolate failures. And how do you work even when there are failures being observed in the system? How do you fail gracefully? How do you recover in time? I think that's a great point.
Yeah, Hystrix was a big part of our systems. And for those in the audience not familiar with it, it is a circuit breaker phenomenon resulting in a fallback for when things fail. And essentially the theory is that everything that is not critical in your system should have a fallback. And so that helps to come up with what kind of chaos experiments to run. Is if I think this part of my system is not critical, I should inject chaos into it and see if it does what I expect it to do, which is execute the fallback. Now we're running these experiments because a lot of the time that doesn't always happen, or the fallback has not executed in a while and we need to figure out what this is. Now the tricky part is it goes back to what I was saying before, figuring out which fallbacks to test and figuring out which fallbacks to fix, because I think a lot of this can get overwhelming, especially as our companies become more and more successful, our systems become more and more distributed, more and more complex, and you could find a failure anywhere, right? You could probably pop up any sort of repository and find a bunch of bugs. That doesn't mean necessarily that it is important or pertinent to fix those bugs and dive into them. And so I think it takes a lot of work on the part of the chaos engineer or the part of the person running these experiments to really understand the user, to really understand how folks on the end are using and testing your system to understand if it's important enough to fix or if it's important enough to go down.
On that note, I'd just like to add one small point as follow up to what Nora was saying. If you get a chance, do take a look at the talk from yesterday by Sudeepa Prakash from Amazon Prime Video, where she spoke about a team resilience score. So they have this concept of a team being assigned a resilience score. So they're responsible for some part of the service. And there are certain factors that you have that determines the resilience score, with weightage assigned, the deployment safety, how much you've tested, what's probably for how long has the system been running without issues, and a lot of importance is given to what you're trying to proactively fix. Nora talked about what paths to test, what paths to fix, what to prioritize. A lot of that is determined based on the feedback that you're getting in from your field engineers. A lot of that is coming in from your own analysis of your system, then how you apply that and ensure that your system stays reliable. So I think that's a great way. It just sort of occurred to me that that's a great way and that's a great idea. Maybe we should take a look at it.
Excellent. We have a question. And Joab, what do we got?
All right. It's from a senior staff engineer, Pranav Singha, and basically it's about ROI. Cloud native architecture is expensive. How can we map different KPIs and chaos experiments to ROI? And what is the cost advantage of chaos engineering apart from the definitive reliability and resilience?
I could probably add my 2 cents there. Just the flip side of it, right? The converse of this question, outages can be extremely costly, right? We've seen that happen in recent times. You could burn millions of dollars because of an outage, and it's probably worth investing time and effort to ensure that doesn't happen. So that's real value for money, I would say. And yes, cloud native architectures can be complex. There have been instances, and I've sort of seen this personally when speaking to practitioners or budding chaos engineers in different organizations. It takes a lot to actually, or maybe you can call it as an investment. It does take a price and cost to set up the right observability and right infrastructure for you to do the chaos testing. So that can be an initial deterrent. You could start small, definitely, and you could get used to the practice of chaos. But your actual value comes from environments that you have set up for scale, which is sort of mimicking production traffic, or maybe has some amount of traffic diverted there, things like that, right? And to do that kind of a setup, it does take time and it does take effort and money, but it's really worth it because outages are just too costly, not costly only in terms of dollars, but in terms of reputation and a lot of other things, right?
Time, effort, and money. Charlotte, you must hear a lot about that.
I do, but honestly, this is hard, right? You can't, well, or it is very difficult to actually map an ROI on the advantages you get out of chaos engineering, right? Because as soon as you improve your system, that usually leads to people also having more trust in the system, developing faster. So you kind of get this follow up on each other. And that doesn't really help you, right? So you can't really say we've improved this much, so now we can put this price tag on it. So therefore there's that. So I think a lot of it is non-tangible things like now we trust our system more. We have hopefully less downtime, but exactly this kind of thing is something you can't put a price tag on properly, right? This is where it gets hard. So that's where you have to find other ways to convince people of the value of it.
Maybe you need to count it in terms of, go ahead.
I like that a lot, Charlotte. It's very hard to measure the incidents that you don't have because you're not having them, and you're investing in the expertise and the dissemination of that knowledge, like with your coworkers and with your employees. I really like to take a qualitative approach with chaos experiments and ask people how they think the system works and how they think it fails, and then ask them that same question again afterwards and see how that answer changes and evolves over time. That can be a really good way to measure it, and it can be a really good way for you as the person leading or running the experiments to get a sense of how people are reasoning about their system. Charlotte, I actually think that the customers that you work with are probably in a much better place than some of the larger scale organizations because they get the benefit of designing some of their systems from the get-go. And so they can decide before they even start writing code what the KPIs are of those systems and how they're supposed to fail and how they're not supposed to fail. Whereas like some of the larger organizations, they might be thinking of that kind of stuff now after the system has been written, and they're kind of in a more difficult place. And so I feel like your customers kind of get the opportunity to start these good habits early on.
And learn from the people who had to go through the hard times. So now we get to
Absolutely.
reap the rewards. That's nice. Yeah.
Absolutely. I think we heard this Lenskart story a couple of sessions back, right? So I think along with what Nora was saying, sharing experiences, how other enterprises have learned it in a hard way. How hard was the lesson, or what's the price tag to learn a lesson out of it? Sharing such experience actually has really worked wonders along with Nora, what you were saying. So it's kind of questionnaire to ask certain questions again and again. How prepared are you to handle such failures? I think stakeholders understand the need for it, right? So definitely, it is definitely a costly investment, but it definitely good things come with the big price tag. So we have to accept the fact, yeah. And ROI, it takes long time. It definitely a long time to tell or convince how we were able to increase the system uptime, which you were operating 1 year back. This was your uptime, and now this is how you are operating. Your availability has increased, or the MTTR has on an average, you could see a very big numbers earlier, but now we were able to quickly resolve problems. All this, it takes time to collect the metric and project it to the management. We need some data points. So we cannot tell, and there is no one single method of calculating ROI which works for all the enterprises. That is other fact too.
I get this sense of like almost, are there ways to measure like just the culture of the organization and how it behaves when there's lots of outages and downtime and everything else? Then when you start placing in chaos engineering, like you can almost sense like there, a gradual calm in many ways. Is that part of the equation at all or not?
If I can jump in here, I think some orgs can get into a place where they are experiencing a lot of incidents and experiencing a lot of stress. And I think with the introduction of chaos engineering, but also the introduction of like actually taking the time to learn from their incidents and retrospect them properly, I think with both of those things, you'll have a culture where it's not like you're having less incidents or calling less incidents, but incidents are not that big of a deal. They just become everyday work that you're working through. You know who to call, you know who to bring in, you know how to solve this thing. The incidents will never go away, right. but the ability to deal with them will be so much stronger. And it's a muscle that you're exercising, that you're practicing all the time, and that you'll notice that people just feel better about their systems. And when they do have an incident, they're like, no big deal. We've practiced this. We've got this.
I think that practice is important, right? Because you can't suddenly expect people to be better at dealing with stress and working as a team just because you add another system, right? This is a big thing. We see that just because people pick up cloud native technologies, the culture doesn't immediately adapt, right? So it takes a while, and it takes quite some effort to actively work against previous habits, from blaming to instant firefighting to not looking back afterwards. All of these are things that happen to come up again and again. And then just adding chaos engineering wouldn't fix that. But I think if you look at the culture piece as well, combining that, I think that's something you can practice, and that's something you can learn.
We recently had Adrian talking about something called the chaos first principle. So that's basically looking at chaos right from the beginning. Like Nora said, I think smaller organizations are definitely in a much better place to deal with that. They don't have to do things retrospectively. They can start by thinking about all these outcomes and begin that way.
Joe, do you have a question?
Yeah, one listener had noted that most of the tools out there today, like Litmus and Gremlin and whatnot, are still evolving. Are there any maturity model, or is there any maturity model for chaos engineering in place? I know that the Litmus folks are talking with CNCF, and they have a working group going, but I'm not sure if this will, what they will develop will span across these different tools. But yeah, what is the maturity model for chaos engineering?
That's a great question. I'll probably try to take a shot at that. Yes, there is a CNCF working group, that is started for chaos engineering. There was one before. We went cold for some time, but now we've sort of started it once again. And it has a representation from different chaos projects, folks on the vendor side, practitioner side, etc. So there's definitely something that we're working towards. A white paper initially, and a maturity model might follow next. And this is a very subjective question. I think there's no one way to define the maturity of a chaos engineering practice. Yes, all these KPIs, lesser incidents, lesser tickets, all these are definitely qualitative indicators. But when it comes to the actual practice, the way the operations associated with chaos engineering or the tooling, let's say maturity models are generally applied to practices and tools. So if you would do that, and if everyone has to come on the same platform, agree to that will take some doing. But there are a few things that we can sort of think about as leading to that. What all can your chaos tooling do, or what does your chaos practice encompass? Many organizations have a hybrid infrastructure. That is the truth today. Maybe that will change in some time, but there are a lot of organizations running some services on Kubernetes, maybe some less critical services that they manage to migrate. Something is still running on their own data centers. Some part of it is in the cloud. So do you have the right way to address all these targets? Do you have the right observability setup? Do you have the ability to schedule chaos on demand and also run it with some kind of a schedule or random schedule at predefined intervals of time? Maybe you're looking at multi-tenancy. You have a chaos platform in an organization. Different teams operate different microservices or are responsible for different microservices. So they want to come onto the same platform. What is the level of multi-tenancy that your practice and platform allows? These are some of the things that you could factor in. These sound like features, but they're as much operational challenges and constraints to a chaos practice as much as they are features of a tool. So these are things that you would probably think about. And what is the type of attacks that you have? How can you integrate a particular solution with CI/CD platforms or hook it up with observability tools? What is the extent of visualization that you get? Do you get recommendations based on certain failures? Nora talked about learning from incidents. Does your system prompt you to run a particular attack on a particular component because that is vulnerable and probably has been known to be susceptible to certain issues? These are things that we can keep adding to your list of to your wish list, and based on what you get, you can create a maturity model. You can rate yourself as to where my chaos practice stands today. But yeah, that's just my thought process.
Karthik, that's a very good point. Just one additional perspective I would like to add here is, as we move on, right? I mean, not just looking at the detection and recovery. I think as we move on to the next level of higher level of maturity, there has to be a very important perspective that has to be factored in is how preventive we are. What kind of a preventive measures we are taking will become a very important factor as we mature to the higher level in the ladder, right? So in terms of how proactively we bring certain toll gates, how do we tighten up the toll gates right from the architectural design? Have we bringing the infrastructural architectural constructs before even we get into validation mode? That becomes a very important. How preventive we are, not just looking at how reactively, how effectively we could identify the problems or how effectively we could fix the problems, not just the shift right part of it. There has to be a lot of maturity at the leftmost part of it to prevent. How am I matured? How my thought process have matured to help me to build, which means we should start looking at resilience baked in the application, not just as a sugar coated, like how I made the pancake. I did some toppings on it. So it not just looked as a toppings, but rather the application has to be baked in, built with resilience. And that requires a lot of, actually, as we mature, there are a lot of shift. I would say a lot of cultural change has been really mandated, right? And it is not just one persona who's going to have a very big impact. So across different personas, be it architect to developers, be it quality engineers to infrastructural engineers, we see a very strong difference in the personas, the responsibilities of each of the persona. And resilience engineering, I personally feel it is not just one persona who contribute majorly for it. I think all these different personas join hands together to make this as a possibility, and it is a journey. And you have to start with small, and as in with any other practice or with any other capability, start small, and it is a journey. You have to mature, and as you mature, bring a lot of focus in the shift left activities to proactively bake in with resilience, not just bringing maturity in validating or detecting and effectively fixing the problems. That is something, an important factor that has to be considered when you move up to the higher level of maturity.
Absolutely. I think one of our users on a lighter note came up and told us, gone are the days when I had to convince my management about getting Windows for doing chaos testing on the platform. Now I'm hearing chaos and resiliency being spoken more about in meetings. There is some kind of talk about budgetary allocations for resilience and chaos testing. So I thought that was a great success story for us. But yes, resilience is not just your tooling or what you're testing. It's a lot about mindset, how it can be baked into your processes, the architecture right from the beginning. And I completely endorse that view.
Have you ever noticed that it comes up more for companies or clients who might have gotten burned once or twice? So I feel like there's this initial hurdle before people take it seriously. And then if something happens, and then it's like, oh yeah, we should have done this before. I feel like that tends to bring people on the side of fans from more apprehensive.
That happens. That's happened a lot of times. But there are a few cases, at least, where it sort of happened organically without them really burning their fingers. So yeah, I think we are on the progressive path.
Charlotte, what you said reminds me of that comic where it's these two folks pushing a wheelbarrow with a square wheel, and someone goes to hand them a round wheel, and they're like, no, we're too busy. We're trying to push this square wheel. And if they just took a second to change the tire, like they would have a lot better route. But it's that second that pops off to change the tire that people are not willing to do. They're like, we're too busy. We have way too much going on. But if they just take a beat, they'll end up getting there faster in the long run.
That's a great point.
Absolutely.
One of the questions that I have is about, when you think about these tools and how they're becoming available to people with relatively basic skill sets in database administration and network management. And this is a trend we've seen for many years, where more and more tasks are being left to people who maybe weren't trained as a networking engineer or weren't trained in some specialty skill, but now the tools are available that allow them to perform the tasks that maybe a network engineer had done in the past. And Chaos Native CEO Uma Makara made this point that people in these professions are becoming SREs, and the question's a bit cut off there. But the follow-up to that is, I'm curious on how these individuals are making this leap with the skill sets that they have. How are they making this jump into these SRE roles? And does that, is there a kind of a factor of low code that we're seeing as a trend? And what does it mean for dealing with the complexities, that we have with cloud native? Anyone is open to answer this question. I'm just looking for ways, are the skill sets of people who maybe don't have cloud native technology background, are they able to kind of get in and start making a difference?
I think I'll probably just take a quick shot at this. I think the experts still have their place. SRE continues to be a specialized role, but there are more SREs, more people coming into that specialized role now. But one thing that has really changed is the fact that Kubernetes and the entire cloud native evolution that you can call it has really democratized software engineering to a whole new level. People who were just not bothered about storage, for example, or infrastructure. Maybe they were branding themselves as core developers, application developers. Today are talking about persistent volumes and network policies, right? That's a great entry point for people to learn about, everything that goes into making their application work. And that knowledge is sort of enabling people to dig deeper, understand more about the impact that their code is causing. Maybe they're getting into the operational aspects like never before. And that is true for the other disciplines, not just application developers. I use that as an example, but same goes for the others as well. You could say the same for the other side of the coin as well. People who are traditionally infrastructure folks, as you would call them, are now using infrastructure as code. They are coming into defining how the application should run. So they are having an inkling of what the application should do, what should be its high availability policies, what should be its security policies, and how that can be coded up, stored, how can that be automated. A lot of that side of it is coming in here as well. Low code or no code, like you said, that is a huge trend. It's a huge umbrella of a lot of things. I think traditionally people are using that term to refer to, use some kind of visual drag and drop approaches to building out transactional parts of microservices. But you could also say YAML or rest of the other infrastructure as code technologies that are coming in today also fall somewhat under that bracket. And that is enabling a lot of mixing of personas, a lot of ideas being shared. And yeah, the result is you're having a lot of people who are calling themselves DevOps engineers. They're able to transition into these specialized SRE roles. I think that's definitely a contributing factor. And Kubernetes is sort of at the center of a lot of this, I believe.
I think tools like Litmus also make it really easy to get started, right? I tried it out, installed 5 minutes, then you can run your first experiments without actually having to dive too deep into it. So it lessens the entry barrier and lets people take the time to actually learn about it and then grow their skill set that way.
Thanks for saying that. Makes my day.
Joe, do we have any more questions?
I have a question myself, actually.
What
right. impact does good chaos testing have on SRE? Is there a way to do chaos testing and stay above the SLO, or just what will be the impact for the end user in short?
The SLOs usually deal with unplanned outages, right? So if you plan your chaos testing in advance, you could say it's a maintenance window, but ideally you'd start in a way that it doesn't impact production from the start, right? So if you're not sure if something's going to be impacting your production environment, you might want to have people on standby, and you might want to test in less critical environments first.
Yeah, you should. I mean, this goes back with the prep work. You should never go into an experiment with the hypothesis that it's going to fail. However, you should be prepared that it might. And so understanding what we might do if this thing fails, all the ways that we think it could fail before we press that button, before we run that experiment, are absolutely paramount. If things do go out of hand, making sure people are on call. I actually recommend a Slack channel where people are coordinating the whole thing the entire time for larger experiments. That's going to be really important, and understanding who to page if things go out of whack as well. But ultimately, like, what's going to happen is it might turn into an incident, which it's an incident that was remaining latent in the system anyway, and now you have a lot of hands on deck to go deal with it. So I would argue that is a better place to be in than a random incident occurring.
Nice. All right.
I think also chaos engineering helps you to create new metrics and define new SLOs that you might not have had a chance to think about earlier. Maybe the scenario forces you to look for information, and maybe you don't have it, so you end up creating some metrics, you're shoring up your observability, you're instrumenting your applications to give out more information. That's a side benefit of chaos engineering, an indirect benefit of chaos engineering.
Wow, great.
I'd like to just in conclusion, put a little twist on our conversation and ask either of our panelists, are there questions that you have for each other at all? You probably have some thoughts going through this conversation about what you've heard and kind of maybe piquing a little bit of your own curiosity. Anyone have any question for anyone else here?
I have a question for Ramya. As a resilience practice head, what have been the challenges that you faced, which, let's say, you're solving by chaos engineering? I know that outages are common and there are a lot of business angles to it as well, but have you seen a tangible benefit of chaos engineering? I saw a question on chat recently by Dushyant, which said, is there any instant gratification that we can get by doing chaos engineering, make ourselves more confident? Have you had an opportunity to feel more confident about your product and your team because of chaos engineering? That's a question that I had.
Okay. So that's an interesting question, Karthik. So yes, definitely when it comes to instant gratification, yeah, as I was saying, we carry out certain attacks and we identify some pitfalls. It gives you a lot of happiness that you saved your system from a production outage. You get that proud. You have that proud feeling. Definitely will feel that. But in general, if I look at practically as a practitioner, when I look at things in bringing or maturing resilience engineering for organizations, actually it has to, the dots get connected, right? So when I look at how do I improve, right, and it is not just about bringing chaos engineering. Can I make things work? Just bringing chaos engineering, I cannot make things work. So if I look at, they would not have a matured shift left practices. Okay, so they would not be doing I'm basically from a performance engineering specialist, so I could see without having a very proper performance engineering practices in place, just jumping onto chaos engineering, it cannot be just jump around without taking that systematic route, right? And without having a proper redundancy, businesses have not even invested or have plans to invest to have a high availability. So they expect to have 5 nines and 6 nines, but when I end up explaining, it comes with a cost. So you need at least 3 availability zones. When it comes to think of 5 9, then they step back. So actually when it comes, I could see practically is, they have a lot of vision to increase the system uptime, but when it comes to actuals, what does it make? What is the effort requires? What is the investment required to make that happen? Sometimes some enterprises step back, and I think all this happens because they have not really burnt the hand. But enterprises which do not even have proper fund, they're ready to invest anything and everything, who have really burnt hand and they had a very big outages, so they don't have thoughts to think whether I have a business priority. And I end up spending a lot of time convincing product owners and various business stakeholders why it is important, why that investment is mandatory. But I have felt practically on the ground that there is no big way it has solved the problem. The only place where the problem was easily solved is they had burnt their hand very badly through a problem, through a outage, right? So only in such cases, businesses, even if they do not have fund, they are really happy to invest to avoid that. Okay, so that is one perspective. And again, chaos engineering is not just applicable for one persona, Karthik, right? So it is developer take a very important responsibility to bring chaos experiment as part of their development environment. And performance engineers, definitely, it is not just about bringing outside in failures, which are usually possible by running stress test. So we have to have tests conducted, load tests conducted along with chaos experiments, where we try to break the system inside out. And not just with performance engineering personas, you have to take the journey all the way to shift right. ensuring making chaos engineering as part of your production day in, day out for SRE persona. So there are different personas who are involved, and equally they have to do their responsibilities. Only then it becomes a possibility, and the dots get very connected very easily. Performance, scalability, availability, resilience, reliability, all these entities, it at a high level, it looks these are different NFRs. But if you look at from a failure perspective, all these dots get connected very quickly, and you need all these in places. Just having one is not going to solve the problem, and that has been a problem. We start with something and we end up giving a recommendation, a roadmap planning, telling we need to invest on SRE, and customer would be thinking where we started and where we are landing up. So these are connected pieces. So that's all, and I could make it. So we need to have this entire ecosystem in place. It is not an individual a topping that can make things work, but you need the ecosystem. That has been always our experience as a practitioner, Karthik.
Thanks. I think that explains.
Wonderful. Wonderful. Well, I want to just thank all the people who came to this breakfast. Thank you so much for your questions, for listening. And I want to give even a bigger thank to our panelists today. Karthik, thank you so much for helping us lead this conversation. Ramya, your insights are terrific. Charlotte, thank you for that customer perspective. I really enjoyed that. And Nora, you definitely have the knowledge here. So thank you so much for your participation. I want to thank Chaos Native for sponsoring this Pancake Breakfast. Thank you very much for making this possible. And enjoy Chaos Carnival, everyone. And we'll see you soon. Thank you very much.
Thank you.
Have a great conference. Thank you.
Bye-bye.
Bye-bye.
Bye.